Hello everyone, welcome back to our channel. So in this video, this is the first video of our graph playlist. So in this playlist we will be discussing some core concepts and terminologies and graphs, and further we'll move with solving some lead code problems. Okay, so let us start the video. So first I would encourage you to watch our tree playlist, if not just the starting 10 videos, to get some basic idea of trees, so that you would be comfortable watching the further videos and graphs. Okay, so first I'll discuss what we have done in trees. Okay, first I'll make a simple tree over here. So it is a binary tree, we can see. So I'll write some characteristics in this tree. That in this tree there are no cycles. No cycles in tree. We can see that there are no cycles here, and there will never be a cycle in a tree. Okay. The next property we'll see that each node can have at most two child. Yeah, right? Either a node will have zero child, or it can have one child, or it can have one child, or it can have two child, but not more than two, right? And the third characteristic would be that there is a root node. There is a root node always. This is important, always. Root node always. There is a root node always. So these are basic three main characteristics in a tree. Now we'll discuss. Now we'll start with the graphs. Let me make a simple graph over here. And like this, right? So this is a graph. Now we'll discuss some of its characteristics. That, wait a second, I'll make a partition. So these were of tree. Now I'll write the characteristics of graph. That in graph it may or may not contain, cycle. It may or may not contain cycle. Another is each node can have any number of connections. Each node can have any number of connections. Just like the child we spoke in trees. Here there is a connection, because we can see that in trees there is a direction, right? But here in this all are individual. Okay, so all are individual. So I'll call instead of calling child, I'll call here connection. Okay, each node can have any number of connections. Third characteristic, that there is no root. There is no root node. That if I want to traverse this graph, I can start from any node. If I'll start from this node, I can traverse the graph. If I'll start from this node, I can also traverse the graph. There's no problem. So there is no root node. So these are some differences in tree and graphs. Now we'll proceed further with more characteristics and types of graphs. Now we have types of graphs. First type of graph is a directed graph. Directed graph. So what is a directed graph? Just like in tree, we have seen that this is a suppose this is a root node. It having left child and right child. That is, we can go from root to its child, but we cannot go from child to its parent, right? So that is a direction. That is This is telling a direction that we can go from this node to this node, but we cannot go like this. It is not bidirectional, right? Like this is kind of a directed graph. We can see that tree is a directed graph with no cycles, right? So this is a directed graph. Now second is undirected graph. Undirected graph. So here there is no direction. That is we can go from anywhere. Like from this node we can go to this node, and from this node we can come back to this node again. So it is kind of bidirectional. That's why it is called undirected. There is no direction. We can go anywhere in any direction, bidirectional. Okay. Now, like in same way, we can have directed cyclic graph. That is graph which is having direction as well as cycle. Like this. It is forming a cycle and also having a direction. Directed cyclic graph. Okay. Or we can also have a directed acyclic graph like this. It is having a direction and there is no cycle. That is directed acyclic graph. And for this we can have undirected acyclic graph or undirected cyclic graph like this with 4 nodes. It is undirected cyclic graph. Okay. Now we will discuss some basic terminologies that we will be using throughout. Some terms like what node we have seen in trees, that every like object, these are like objects connected to each other, these are called nodes, right? And then another is edges. This is an edge. An edge connects 2 nodes. This is an edge. Okay. And or like a node, even we call this as a vertex. This node can even be called as a vertex in graph. Like node can also be called as a vertex. Okay, so like these both are mostly used in graph. And one thing I wanted to tell you regarding connected graphs and non-connected graphs. Mostly people get confused over here, but it is very easy. That this is a graph where all the edges are all the vertices, all the nodes are connected. Okay, so this is all a connected graph. But if we say that this is a graph but it has 2 parts and these are isolated, these are not connected, so if I start traversing from here, I cannot cover all the edges, I cannot cover all the vertices, because if I'll start from here, I'll come to this node, then to this, then to this, and from here I'll stop traversing because I am not connected to further nodes. So this is called unconnected. This is called unconnected or isolated graph. And here if I start traversing from this node, I can traverse entirely to all the nodes. So this is called connected graph. Okay, so I think this much is enough for this video. Further more concepts we will be discussing in the further videos. So thank you for watching.